Hello colleagues, today we are going to discuss a kitchen block design process based on existing model of a house. It can be imported from AutoCAD, CATIA, SolidWorks, ProEngineer, or architecture-based CAD systems such as Revit or many other CAD applications. In most cases, your design can adapt to the changes in the original model. We will see the workflow on layout model made in Autodesk Inventor. Since the house was modeled in a skeleton design way, let's go to the bottom level and add concept of a kitchen block. It's easy to do this, being in a feature priority, with a double click on any skeleton-driven part. Use section to clearly see the working area. On a new sketch, define a general shape using constraints and dimensions. Now a new solid body can be created. Extrusion extent will match height of a column nearby, and the shape of a kitchen block will wrap around it. The descriptive name of a solid simplifies navigation. Now it can be converted to a new part that is still related with a layout model. First, let's create a parameters to define the thickness of the body and the niche panels. The work plane is offset from the back of a cabinet by the panel thickness. It can be used as a reference for a separator and as well as a limiting factor for a niche. Now the shape of a rectangular niche can be created on the front. The work plane will be used as a limiting factor for a cut extrusion. And once we have the final shape, it's time to use Woodwork for Inventor feature to make the panels. First, let's make a separator that goes along the cabinet. You can choose a solid and the intersecting plane to make the panel. Then you need to select the thickness of the panel. In this case, we can choose it from a previously defined parameters. Then we need to set the direction. That's it. Outer panels can be generated in a similar way, but in this case, we need to pick the face of the box. The front and back panels will be converted to door leaves. Therefore, I'll make them thicker by 2 mm, and later this excessive thickness will be reverted to the right value. The niche will be made of a thicker, solid wood panels, so we must change the direction and the thickness parameters as well. Internal panels can be made as an intersection between the concept solid body and work planes that divides cabinets into 3 segments. When you have a work plane in the right position, then it's important to choose the right position for the panel. It's time to make an internal shells. If needed, you can make panels using regular Inventor features such as sketching and extrusions. When the new sketch was created, it's convenient to use slice graphics to clearly see what happens inside in the model. In our case, shells will be simply rectangular. They will be not the same in front and back, so that's why I'll define them like a separate sketches and make separate solids afterwards. And later on, they will be converted to separate panels. Now it's time to split internal panels to make the right construction. So first, let's change the visibility, keeping only the panels we need to process. One of the panels must be removed, since it does not fit in the dimension. So as you can see, the other panels that's already built slightly offset from the one I removed. The panels on the left must be separated as well. So now we have a top and the bottom panel separated. Despite that we split the panels, they are still intersecting, so I will correct that using Woodwork trim command. In this case, facades will be used as a boundary that trims the intersecting panels, and the same will be done on the front. As you notice, some of the panels was not cut completely, and this happened because each panel we split it using Inventor trim command, produced two new solids that are not treated as a panels of a Woodwork for Inventor. Let's fix that by setting the board type for the solids. Now we can do the trim operation for all remaining panels. Split command can be used again to split facade panels into door leaves. They are still too thick and there is no spacing between them, so let's make a sketch to fix that. I'm projecting cut edges, converting the results into the construction geometry, and making an offset to define how big the spacings will be. The extrude command with intersect option can be used to make spacings and reduce the thickness of the panels in the same moment. As you can see now, the door leaves are in the correct shape and the correct thickness, so the same can be done on the opposite side. Since we have finished the skeleton design stage, solids can be converted to new parts and then combined into a new assembly. As you can see, there is no constraints needed, everything is on a place already, so it's time to save the work before going to the next steps. Now the material groups can be defined. In my case, I will set the body 03 type of a laminated board for entire assembly, and then solid wood panels will be set to a niche. You can just overwrite existing laminated board material, and in this case it will be faster than picking the panels separately, especially since we have some internal panels, so that makes the workflow a bit easier. Let's hide the niche components to have a good access during the edge band assignment. To do this, you need to select the type of the edge banding and define its position and thickness. Here you can switch to all faces mode to speed up an assignment of an edge banding around the doors. Once it's done, we can hide the doors for a while to set the edge banding for internal components. However, in this case we need to use single face selection mode, because we don't need to go all around. When finished, you can use highlight to make sure that there is no missing edges, and as you can see we missed one, so it can be easily fixed. Now the work with materials is over, and we can move to the next step, which is hardware placement. It starts from making some reference work planes to define the centers of the components. Now the hardware can be chosen from the library, and you can choose a configuration of a components as well. To place a component in the right position, you need to match the item in the list with the object on the model. In our case, since the back panel and the front panels are slightly misaligned, we're getting excessive amount of items. Some of them need to be deleted. We can attach the hardware for shelves. Once it's done, for a single shelf, you can multiply them together with hardware items using the pattern features of Autodesk Inventor. Because I want to stay focused on the workflow, I'll skip a few identical steps and we will see the model in a final state when all the hardware is on place. So now it's time to set its configuration in the right way. To clearly see what needs to be adjusted, all the panels can be disabled. Thus you can still see the shapes of the parts and you can control the configuration of the hardware that joins them. Let's find one of the items that need to be reconfigured and change its options. Now it can be used as a reference to change the others. Again, I skip a few identical steps to save your time, and once the configuration is set in the right way, then the holes can be generated. As you can see now, the part geometry has changed, all the holes are exactly in the right places. Next step is the generation of the bill of materials. BOM is model-based and highly adjustable since it's templates-driven, which reduces the amount of routine work and reduces the chance to make any mistakes. Of course, bill of material can be exported to Excel file. It can be easily adjusted to meet the needs of information consumers in your company. Now let's move to the drawings. They are also template-driven, which makes them highly adjustable, and they include all the information you might need for the production, such as grain direction, dimensions, hull table, material, codes and names, etc. In some cases, you can even skip the drawing generation process since Woodwork for Inventor allows you to directly generate CNC programs based on a parts geometry. You can define CNC configuration and set the rules how to generate the CNC programs. And what is left to do, just send the programs to the CNC machines. programs will be generated automatically based on the model. Moreover, you can also generate panel nesting layout that can be exported to the CNC machine as well. Now let's bend back to our original model and add newly created cabinet in it. Since we have related it with the original concept, it will be positioned on the right place automatically without using any constraints. Moreover, if you need to change something, you can change concept file to define new size or new parameters. That's all the information I wanted to share with you today. Hope you like it. Thank you for watching, and we will see you again in our next videos. Good luck and have a nice day.